Hi, so let's have a little look at something new inside of Maya this week. Looked at Camera Match the week before. We're going to firstly go up to the top right hand corner of your screen, and you may well be looking at your interface and it'll say Maya Classic or Maya Classic. I still haven't decided. It's bad, isn't it? Maya Classic, and we're going to change that to MASH. And basically, we're going to have a quick look at what is, in effect, a physics engine inside of Maya. I'm not too familiar with it, if I'm honest. I have historically used one inside 3ds Max, but I've read good things about this particular physics engine, so we're going to have a look at some of the basics. I think they're going to be pretty appropriate for the work that we're going to be doing in the assignment. So here we go. So first things first, let's create ourselves an object to work with. So I'll just put a little cube out there. I'm going to just scale that slightly. And if your interface doesn't look the same as mine here, it's probably because the MASH tab hasn't been clicked. So make sure you've got this one activated, MASH here. And once that's clicked, click on this button here which says basically create a MASH network. So click that, and the first thing you'll see is that your object, your cube in my case, has been replicated or instanced 10 times. I'll just show you what that means. Okay, so over here on the right hand side we'll go to the underneath the attribute editor, we'll go to the MASH1 distribute tab, and inside there you'll see the number of points. It has a preset of 10. You can change this anytime you want, but 10 is good enough for what we want at the moment, so I'll just put 10 in there. Importantly, if you wanted to change one of these objects, you basically have to go back to the original, which is this one over here. It's hidden, the P cube, and you can rescale it there. And you see that if I scale one, they all become scaled simultaneously. That's the beauty of things being instanced and not copied. A copy is like an independent copy of another object. If you change one of them, the other one doesn't change. When you make an instance, everything that has been instanced will change if one of those elements changes. So that's the value of it. So we've got these blocks here, which we now have 10 of. I'm going to go back into my distribute tab. Now, sometimes I find that when I'm working in Maya, I go back to find the tab and it doesn't seem to be there. And if that's the case for you as well, my workaround has been go to Focus and then go to MASH, and we'll get back to distribute that way. So sometimes I guess there are that many potential tabs opened that the program kind of, operates by a system of intelligence, if you like, by closing down X amount of tabs and highlighting some of them. And you can get them by just clicking on Focus. Anyway, here we are back in this MASH distribute tab, and we're going to change the distribution type from linear to grid. And you'll see that in my grid options I've got 3 by 1 by 3. Well, I'm going to make that 5 by 5, and I'll leave the other one at 3, and I'll look at the distance, and I might put in 7 by 7 by 7 just to give them a little bit of breathing space. Okay, so there's my little grid of instanced geometry. So at this point in time, if we simply, I didn't mean to do that, scaling those, leave that alone. So go over to the outliner and just have a little look at what we've got in here. We've got our MASH network, and above it we've got the actual mesh. The mesh object is now called a repro mesh. And what we're going to do is we're going to go to the MASH editor, and if we click on the little plus key, we can add a dynamic element So once you click it, it becomes obvious that there's the dynamic element. It's been added to the mesh layer. And you get this new yellow dotted section on in your workspace. If you go back to the outliner, you'll now see something called a bullet solver. I have no idea where this name comes from, but anyway, basically this tells you that there is a dynamic, a physical or a physics dynamic operating in the scene. And you'll see the effect of this now if you just simply hit the play button and watch what happens. Those objects now have a physical property of their own. They're acting basically like physical objects in the real world. And we're simulating this, obviously. Okay, so just let that simulate. What I'm going to do, I'm going to increase the length of the animation. So let's make that 300. And by 300, perfect. Go back to my dynamics and going to use the little rewind, go to the start of the playback range, and in we go. You'll see a little bit more this time around. As the cube slide across, it's like they're hitting a bed of ice and they're sliding across a bed of ice. I guess there's not much friction in there, so maybe what happens if we increase the friction? Does that stop the flow? Yes, it does. So okay, we've got a whole bunch of things to play with in here in terms of friction, damping, bounce. Let's increase the bounce. It's bound to be interesting. So let's put it back to the beginning. Hit bounce, increased, and okay, so they're a whole lot more dynamic. I'll do that again. Just move that whole scene up a little bit. Yeah, there's some good bounce in there now. Okay, so we've also got things like mass, so you could increase the mass, you could increase or decrease the velocity. I'll just increase I think I'll just try the velocity and we'll see if we can actually slow that down a bit. I'm just experimenting like you'll be experimenting and see what happens. Maybe I need to put mass on for that. Yeah, that doesn't feel any slower. Let's see what's going to change the speed and mass a little bit. So let's just change the maximum rotational velocity down. Maximum velocity is pretty low. I've got the mass set at 3.86. No particular reason why. I'm just putting a 5 there. Give it a little bit more weight. And see, that creates a slow motion. Yes, it does. There we go. A bit of a slow motion animation. We may not even get contact by the time the frames are over. Are we going to get it? Not quite. We'd have to lengthen the animation to see that in full. But you get the point of that. Okay, so far so good. That kind of works. I think that was up there. I'll turn that off. Just run that again. And we're back to where we started, which is fine. Okay, so that's really quite a simple thing to get up and running, and you can imagine textured, lit well, good camera angle. This could start to get interesting. Okay, there's a lot of experimentation to be done, but the principle seems pretty straightforward to me. It's certainly easier than I remember in 3ds Max, I have to admit. Okay, so let's add something additional to this animation. Let's create something like a sphere and look at the position of that sphere. I want to put it down there with the bullet solver and I want to increase the scale. Okay, like so. And I think I'll just leave it about there, maybe a little touch higher. Okay, so at the moment, I'll just rewind. If these they fall on top of the sphere, nothing will happen. We have to add that sphere to the bullet solver in order to give it a kind of physical property, if you like, a physics property, I should say. So let's try that. Go to the bullet solver, over to its menu, and you see where it says Collider Objects. Well, we just add whatever geometry into that window there. But the way to add the geometry is the tricky bit. It's not tricky, but just to know it is kind of interesting. you middle mouse click and hold on the sphere from the outliner menu, drag it across, and now when I hit play, if everything has worked, we will see. We should get a different effect. Yeah, that's better. Okay, that's good. That's good. That's good. Well, that's nice and simple. Fine. Okay, so let's rewind that. This time, let's finish it off by taking the sphere and moving it that way, hitting S, and then coming, just bring the time slider forward to about there. Move the sphere into position, hit S, and move it out position about there, hit S again. So we just created 3 little keyframes, and let's have a little look. And it's too fast. Okay, undo that. So let's just do that again. Let's get it right this time. So I'm just going to delete those keyframes, and I've got to say I find this a bit tedious, the way that you can't just click them. They're so narrow. There must be a better way of doing this. I don't know it yet. Okay, but you can. I'm basically clicking right on the keyframe, right clicking, and then hitting delete with my left mouse button. Really kind of irritating. There's got to be a better way than that. Please find out and let me know. Put me out my misery. Okay, here we go. Let's make this a slightly better timed animation. So back to frame 0, hit S for my first keyframe, bring it to there, and at frame, I reckon about 50. So about there, about frame 50. Wow, it's quite low down. Okay, I think that's going to be better. Say for frame 50 there, hit S, and then at and then frame 100. We'll just move it across again, out of the way. Hit S again, 3 keyframes. Back to the beginning, rewind, and back to the start, and hit play. Hopefully that will connect. Nice. Okay, enough for now. Enough to get up and running and looking at MASH anyway. So yeah, don't forget, top right hand corner, change that over to the MASH workspace, and then you're going to be working with the distribute and the dynamics, and that area there too. And if you get a little bit stuck, don't forget, use the focus mechanism to jump to the bit that you actually want, or the distribution tab or whatever. Okay, 13 minutes, not bad. Enjoy.